Welcome to CSC104, adding behavior into our apps. So in the last video, we started talking about classes and we defined fields inside of classes. Now we're going to focus on adding behavior or methods to our classes. So we'll look at the syntax, how we create and call methods, and then towards the end of the class, we'll look at properties as a way to add behavior and hide our fields. So we're going to get started today looking at classes again, and then adding methods to our classes. And we'll cover a couple things. We'll define why we create methods. We'll look at the syntax for defining a method, and then we'll look at actually calling and invoking the method. So as a reminder, let's just start off with what exactly is a class. And remember that a class represents a blueprint. It defines something in the real world that then we can represent in our program. And remember that a class contains data and behavior. The data are the things that a class has, so the fields, and the behavior are the things that the class can do, which are called the methods. So we showed an example in the last video that a method for a dog, or some methods for a dog, are things like bark, eat, walk, lick, sniff. These are actions that a dog would do, and actions for a button are things like show, hide, click, and resize. Alright, so how do we create a method? Because the syntax can be a little confusing. So here we are inside of our bank account class, and this is a method called add interest. So the first thing to note is, notice that we have curly braces. The things that are inside the curly braces of this method are the code that will be executed when the method is called. Notice how we first have the public keyword. Remember, this is an access modifier, and this is what controls who can see and access this method. So because it's public, that means anyone can access it. This word void, this indicates the return type of the method. This is basically the value that gets sent back to the caller when they call this method. So because we say void here, that means nothing is going to be sent back. Simply the action is invoked, and that is it. Then we have the name of the method followed by parentheses. The parentheses indicate what we call the parameters. These are the things that the method requires in order to do its job. So in this case, it's empty parentheses, so that means we have no parameters. So what happens when we call a method? So here's a little setup. On the left-hand side, we have the main program, so the main method. And the right-hand side, we have a bank account class. So we start off, we execute some random code statements, and then we hit the add interest method. The program's flow stops there, and it jumps into wherever that method is defined. And it executes the code inside of the method, and then it jumps back and continues on where it left off. So the method will finish all of its code before it continues execution from where it left off. That's something that you need to understand. So the way that we call a method is just like how we would maybe access a field. So in this situation, we have a bank account created, we have our balance and interest rate defined, and I access the add interest method by just using the dot operator. I say savings dot add interest open close semicolon. So I just access it by the name of the method. Now, if we step through the flow of this program, it would look something like this. We execute the balance statement, we execute the add interest statement, then we execute the add interest method, which then behind the scenes will manipulate the balance. So you can see over here, the balance changes after that. Because remember, a method is an action, it's a behavior, it does something. So sometimes a method needs information from the caller in order to do its job. And with the information that we know so far, we can actually do that. What we could do is we could create a public field, and then use that field inside the method. So when the caller would use the method, they would assign the value to the field first and then invoke the method, and now the method has any data that we need to pass in. But if the data is only going to ever be used by the method itself, it's not wise to use a field, because now we're wasting memory that's just sitting there for no point. Instead, we should use what's called a parameter. So a parameter is basically a variable that's local to the method and that can be passed in by the caller. So notice here on the right hand side, in the parentheses of the deposit method, I said double amount. This means that whoever calls this method has to supply the method with a double amount. So as you can see here, when I call deposit on the left hand side, I pass in a double value. That then gets passed into the amount variable, and it gets treated as a local variable. So only the deposit method has access to that amount variable, and once the method is done executing, the variable disappears and gets deleted from memory. Now, method parameters are validated as well. So for example, this deposit method requires a double. So if I call it passing in a double, that's completely fine and that works just fine. But if I pass in maybe the value true, that doesn't work. I can't do that. I can pass in the value 500 because 500 can be converted to a double successfully, even though it's like an integral number. And I can't do something like this. I can't pass in a string. So the parameters are still validated. And on top of that, you can also have multiple parameters. So you just separate the parameters with a comma. So for example, this method initialize, if you wanted to call this method, you would have to provide a string, a double, and another double. Now, we also briefly talked about return values. And remember, the return type indicates if some type of information is going to be sent back to the caller when the method was completed. And remember, we looked at void. Void simply meant that the method returned nothing. But on the bottom method, notice how we put in a different data type. We put in bool. So this means that when you call the isOverdrawn method, we have to return a bool back to the caller. And the way that we send something back to the caller is we use the return keyword. So in this case, I'm saying return balance less than 0. Well, balance less than 0 returns a true or false value because it's a comparison operator. So we are sending back either true or false when this method is called. So let's get some practice with methods. Let's go into our first group exercise and start practicing by building a calculator. So for this first exercise, we're building a calculator. And one thing I want to point out is in your lab resources, there's a part 1 resources folder that has a start folder. That's where we're going to begin. We're going to open that up and it has some basic code for displaying output. And our job is going to be to create a calculator class and actually look at performing those calculations. So let's go ahead and jump to Visual Studio. Let's open up the starter solution and let's get started. So here we are in the starter solution of the calculator application. And before we start writing new code, I want to go through program.cs and kind of explain what's going on because the syntax is kind of confusing here. So we start off running the program by asking the user to enter in a first number. We get the first number, we store it off. We ask for a second number, we get it, we store it off. We're doing some parsing because remember, when we read in, it comes in as a string, so we're converting it to a float in this case. Then we enter this while loop, this while true loop. So this while true is considered an infinite loop. This will run forever until we manually exit the loop. And every time the loop runs, we ask the user to enter in add, subtract, multiply, divide, or quit. And all you have to do is type in the first letter of either of these and it will work. Now, the way that we actually figure what they typed out is this line right here. So we're saying console.readLine. So this reads whatever they typed in as a string. Then we're saying to upper. This basically says whatever they typed in, make it all uppercase. And then this right here, this index 0, is saying just get me the first character of whatever was typed in. So if I type in add, or if I type in that, or if I type in this, these will all render to the same thing. They'll render out to an A, because no matter what happens, or even if I type in lowercase add, right, they'll all come out to this last line because I'm converting it to upper and getting just the first character. So I start off by saying, okay, if they typed in a Q, then let's break and exit the program, exit the loop, which will then cause a program to exit. But then I say, let's switch the operation. So if they type in an A, or anything that has an A, basically, then we do the add operation. S operation, M, D, so on. And then finally, at the end, we're going to print the output. So this is the basic idea of it so far. Now we're going to actually start writing some code. So let's right-click on our project, go to Add, New Item, and we're going to create a calculator class. So select Class, and let's call this Calculator. So now I have a class called Calculator, and the first thing we want to do is we want to start building methods to actually do the calculations. So what we're going to do is let's first do an add method. We're going to say public void add. So remember, void is the return type, add is the name of the method, and then in parentheses are the parameters. So in order to add two numbers, we need two numbers. So we'll say float number 1, float number 2. Okay, so here's our add method. Now, you may be wondering, well, how do we report the answer back to the user? We could use a return type, but we're not using return types in this just for practice. In the next exercise, we will. So the only way to send information back at this point is to create a field that's public. So I can say public float answer. So what I can say is, now in the add method, I can say answer is equal to number 1 plus number 2, right? That's our logic for adding two numbers together. Let's do subtract. We'll say public void subtract. Once again, we need two numbers, so number 1 and number 2. And then this is just answer equals number 1 minus number 2. Then we have public void multiply, float number 1, float number 2, and then answer equals number 1 times number 2. And one last one, this one is the only one that's a little bit confusing. Public void divide, float number 1, float number 2. And inside our divide method, this gets a little bit confusing because we can't divide by 0. So we want to check to make sure if number 2 is equal to 0, then let's just set the answer to -1 to indicate something went wrong potentially. And this is even a bad practice. We should maybe even use an enumeration or some type of other way of representing a problem. We could maybe throw an exception, which we'll learn about in CSC 108. But anyway, we're just saying right now answer is equal to -1. Else, if number 2 is not 0, then let's actually do the calculation of number 1 divided by number 2. So we built a basic calculator class that has the logic to add, subtract, multiply, and divide. And the answer for all these is reported through the answer field. So now to make this program work, first to do is to create a calculator object. Okay, so for that one, we'll simply say calculator calc equals new calculator. So I defined the calculator object. Then in the add case, we want to actually add the numbers. So in this case, we'll say calc.add, and we need two numbers. The two numbers are first and second. So I'll say first comma second. So we added there. For the second guy, we'll say calc.subtract, first comma second. It's always going to be first comma second because first and second are the two numbers that were entered, Multiply, we'll say calc.multiply, first, second, and divide, calc.divide, first, second. Okay, so all the operations are now complete. The last thing we need to do is report the answer to the user. So here we're going to output using console.writeLine. We'll say your answer is, and we'll plug it in using the placeholder technique. So we'll say comma calc.answer. Remember, the answer field stores the answer for all of these. And that's the whole program. So let's go ahead and compile and run this, and we should see the program asking us for numbers. So first number, we'll say 50. Second number, we'll say 26. So now what do I want to do? I want to add. Let's see if this works. I'm going to first type add, hit enter. Your answer is 76. That's correct. I could also type in just a D, for example. It still knows to add. I could also just type in A, and it will also add. I can subtract, multiply, and divide, and everything is displaying correctly. Alright, so let's now go do a flash quiz. And remember, with flash quizzes, I'm going to pause for a few seconds to give you time to stop your video so that you can answer, and then if you unpause, I'll then go over the question. So question number 1, where do you define a method? Alright, so classes define methods. So inside of our class, we can have fields and we can have methods. Number 2, what is the maximum number of parameters that a method can have? Alright, the answer here is D. A method can have as many parameters as it wants. I know I didn't really explicitly say that, but it was implied by having multiple parameters. Alright, so naming is another interesting conversation when it comes to methods, because you may be nervous to make your methods too long or too short, but the fact of the matter is you want your method names to be descriptive, right? For example, here we're in a class called bank account, and we have methods called add and not positive. And those are actually a little bit confusing. Like, what's not positive and what are you adding? Right? It's not that clear. So you shouldn't be scared to say things like credit and account is overdrawn. So don't be scared to make your method names long, because ultimately it makes it clearer and easier to understand. Now, another important concept is what we call a method signature. The method signature consists of the method's name and parameters. So this is definitely a phrase that you'll hear often. So just remember, the method name and parameters are considered to be a part of a method signature. The return type is not included. Now this leads to another concept called method overloading. And the idea is that sometimes you'll want to create methods that have the same name, and normally they only differ by the parameters. So for example, in this code, you can see we have 3 methods called add, and they all have different parameters. So the first takes in 2 doubles, the second takes in 2 integers, and the third takes in a single double. So when you want the same logic but different parameters, you can overload by just making sure the parameters differ. So this works because there's no methods here that have the same parameters. We have 2 doubles, 2 ints, and 1 double. Now in a situation like this, where we have 2 methods with the same name, and we have the parameters being both 2 doubles, this gives us a problem. Now we can't differentiate between either of these methods by calling it, so this causes a problem. Now just going back for a second, I want to point out that notice how we have return types here. The return type is not considered when we're talking about overloading, right? So in this example here, even though we have different return types, this still does not work because the parameters are the same. The return type has no effect on this. So now we're going to jump back into an exercise again, and we're going to continue adding on to our calculator. Alright, so here we are back in Visual Studio, and our goal for this exercise is to create a new divide method. Except this time, this divide method is going to do integer division instead of floating point. So if we head over to the calculator.cs, you can see we have our divide method, and we're going to overload this to have another divide method. Now, we can start off by saying public, but the return type is going to change because we're going to report the answer through the answer field, but we're going to return a remainder through the return type. So the remainder is going to be an integer, so we'll say int, and then it's called divide. And then we need two numbers, so we need number 1, number 2, and notice that these are integers because we're doing integer division. Now we have to check to see if we are dividing by 0. So we'll say if number 2 is equal to 0, then we can't do it. We'll just set the answer to 0, and we'll return 0 as a remainder. Now, if number 2 is not 0, then we'll just go ahead and say, okay, the answer is equal to number 1 divided by number 2. And we want to return the remainder through the return type, so we'll say return number 1 mod number 2. That would calculate the remainder for us. So now we have a new divide method. Great. Now if we switch back over to program.cs, we want to now add a way for the user to have integer division. So we're going to add another choice to do integer division. And now if they type in I, we want to do something. So we're going to add a new case in. We'll say case for I. And in this case, we're going to do something. So we created an integer division method. But remember, it returns a remainder. So we want to be able to capture that remainder. So we're going to start by defining up here an integer to hold the remainder. We'll assign it to 0 so we know when it's not assigned. And then in I, we'll say remainder is equal to calc.divide, but we want the version that has 2 integers. Now, if you look at the IntelliSense, when a method is overloaded, you can see that it tells me there's 2 versions of this method. The first version has 2 floats, and the second version has 2 integers. So if we place in first comma second, this is technically calling the float version. And notice how we're getting an error because we're trying to store this divide method that returns void into an integer variable, and we can't do that. So this just proves to you that assigning or the return type is not enough information for the system to figure out which overload to use. So to force it to say to use the integer version, we need the first and second to be integers. So we can cast those to integers by doing this. And now that they've been casted to integers, it knows which version of the method to use, which is this one, which returns an integer, which makes this okay. So finally, we need to fix our output because right now it only displays the answer and not the remainder. So we want to say if we have a remainder, then display it. So we can say if remainder is not equal to 0, meaning we have a remainder, then we'll print your answer is placeholder with a remainder of another placeholder. So then we'll plug in calc.answer and just remainder. Okay. So now we have that output, and then we'll say else if we have no remainder, then we'll place this guy. So if we run this now, so enter a number 50, we'll say 26 again. So I could do D, that's the normal division, but if I do I, notice how the answer is 1, and we have a remainder of 24. So this is now the correct application. So let's jump back to our slides and let's continue on. Alright, so let's go ahead and do another flash quiz. So number 1, overloaded methods with the same name must differ in what? So the answer here is B, number or types of parameters. Yeah, so the parameters have to be different. The return type has no say. Number 2, the method name and parameters together are called the method signature. Is that true or false? And the answer here is true. Yes, the method signature is defined by the name and parameters. Awesome. So in this section, we looked at basically creating methods. We looked at how we can define a method, how we can call a method, pass data into a method, and also retrieve data from the method. Next, we're going to finish off by talking about properties. Properties are a very interesting concept, and we know what fields are, so we're going to now use properties to protect our fields. So we'll define what a property is. We'll talk about special properties like read-only and auto properties as well. So starting with a reminder, let's review exactly what a field is. So remember, a field is simply a variable that's owned by the class. It's data that's stored inside of a class. So for a dog, that would be things like the name of the dog, the age, the weight, and the breed. Right? This is information that's describing that object. And then we have, for a button, we have fields like width, height, position, and text. Once again, the data for that class. Now, there's a problem with fields that we haven't seen yet, and let me try to explain it. Here's the idea. On the left-hand side, we have a class called bank account, and let's imagine that we have a rule for all bank accounts, and the rule is that bank accounts can never become less than 0. They can never go negative. However, the problem with fields is the right-hand side. So on the right-hand side, I create a bank account, I assign the initial value to be $100, and then I subtract $200. And now look at that, my balance is now negative. I have no control over what data is being assigned to my fields, and my rule is now completely ignored. So how can we fix this problem? And the answer, or one of the solutions to this problem, is by using methods. So for example, what I could do is I could mark balance as private. By marking it as private, this now means that the caller of my, or the user of my class can no longer access the balance field. And what I'll do is, to provide access, I'll create two methods, a getBalance method and a setBalance method. And these methods will be used to both read and write the value of my private balance. So the getBalance method simply just returns whatever the value is stored inside the balance, and setBalance takes the value that you want to assign and assigns it to the balance. But notice the big difference here. The big difference is this. Because I'm now using methods, I can add an if statement in to control what can be assigned. So with this if statement in place, the user of this class can no longer make my balance less than 0. It's physically impossible. So now my balance is protected. But the problem with this solution is the right-hand side. Notice the syntax. In order to use this account class or this account object now, I have to call setBalance, and then if I want to say take whatever my balance is and subtract 200, I have to say account.setBalance, account.getBalance minus 200. The syntax is just sloppy and ugly. So what we really want is this. We want the syntax and the elegance of assigning a field, but we want the power and the behavior that a method offers. And literally, that is the definition of a property. A property solves all of our problems. So here you can see this is a property. A property consists of two keywords, get and set, just like we saw with the get and set methods. So with a property, once again, we start off by making our field private. So we hide it from the users. It's private. Then what we do is we create the property itself. the property itself looks very similar to the field, except there's no semicolon, it's an opening block. So we have public double balance, and then inside of the property, we have a getter and a setter. The getter defines when we're trying to retrieve the value of the property. So in this case, we'll return the lowercase private balance. And the setter will update the value. So in this case, we can add our logic here to make sure we never go negative. So we say if value is greater than or equal to 0, then update the value of the balance. Now, you may be wondering, what is value? Where is value coming from? Because in the method example, we had a parameter. There's no parameters here. So value is actually a special keyword in the C# language that represents the value that's being assigned to the property. So when I say account.balance equals 200, that 200 is really being dumped into that value keyword. So this is whatever was assigned to this property. Now, by doing this, this is what it looks like. Back from the caller, look at this. We create a bank account. We set the balance to 100. We print the balance. Then we subtract 200 and print the balance. And look what happened. It printed 100 again. And that's because in our property, we define that if we're going negative, don't update the value. So we don't update the value. So now this looks just like a field, but we have the power and we can add the logic that a method can have. So you may be wondering, well, how exactly is this working under the covers? And basically, under the covers, a property gets translated into get and set methods. So just like we created, the compiler will do that for us. So basically, a property is really nothing more than some syntactical sugar. It's just a way of writing code easier, but when we compile and get down to the low level, it's the same exact thing as get and set methods. Now, properties can also do very cool things. So for example, one cool thing that we could do is we can make a read-only property. And to make a read-only property, it's super simple. All you do is you remove the set accessor. So if we're only left with a get accessor, the only thing that you can do is read the value. There's no functionality for setting at this point, so now it's a read-only property. We can also make calculated value properties. So this property, notice how it has no backing field. This property is really just a mathematical formula. Anytime you try to pull the value of expected interest, it will, on the fly, say balance times interest rate. It will perform that calculation and then return the value. Okay, let's do another flash quiz. Question number 1. Why should I prefer properties over fields? And the answer here is B. They provide more control over the data. That is 100% true. Number 2. I must supply both a get and set accessor with every property. Is that true or false? And that is false. As we saw, we could create read-only properties by removing the set accessor. Number 3. In the set method, the assigned value can be accessed with what? So this is inside the set accessor of a property. And the answer here is D, the value keyword, for sure. All right, awesome. Now, properties can even get simpler because there are times that you'll see properties that look like this. And if you look at this, let's examine it for a second. We have a private field called ID, and then we have a public property that simply returns the private ID and updates the private ID. Notice how we do not perform any logic inside of the ID property. So essentially, this code right here is identical to a public field. There's really no difference because we're not adding any logic. So in situations that you have code that looks like this, you should switch this to an auto property. An auto property looks like this. So notice first, there's no backing field. So the backing field is now gone. We don't need to create it because an auto property will create it for you. And also notice that inside the property, we have get semicolon, set semicolon. We don't have to say return. We don't have to update any values. It knows what to do because this is called an auto property. So this and this are completely identical. Now you may be wondering, okay, so why would I do this over just using a public property? And there's a few arguments for that. One argument is that C# just uses properties, so you should always prefer properties for anything that's public. 2, you could do cool things like this. So if you want, once again, your ID to be read-only here, we can mark the Set Accessor as private. So now this can be updated and assigned inside the class itself, but for all other classes that are using this, it is private set, so it looks like it's read-only from their viewpoint. So you could do cool things like that. And then finally, another argument for always using properties is that maybe in the future you will want to add logic to these, and then since you already have half of it done, it's pretty easy to add the rest. Alright, so we're going to finish up our last exercise by implementing a property. Okay, so our challenge for this exercise is just to make our answer field into a property, because remember I said you should really never have public fields. They should always be public properties. So I'm going to show you the different techniques. We'll start off with a fully implemented property. So the way we do that is we have to make a backing field. So this will actually be defined as private, is it float? Okay, yeah. Private float answer. And then we have to create the property. So that will be public float answer with a capital A. And then we have a get section. And we have a set section. So in the get section, we're going to return answer. And in the set section, we'll say answer equals value. So at this point, we now have a property. So let's try this again, but now let's make this into a auto-implemented property. So with an auto-implemented property, remember we don't need to have this answer variable. So we can delete that, and then instead all we say is get set. We go like that. So now this is an auto property. Once again, everything's still working. And the last cool thing that I can do with this is, since I'm using an auto property, it would make sense that the caller, which is this code, it never needs to change answer, right? Because, for example, I could hypothetically go calc.answer equals 50. I can change the value of answer right now, but there's really no need to ever do that. So I can say private set here, and by saying private set, if I now try to say calc.answer equals 50, notice how I get an error. That's not okay anymore, which this is good because I am now reducing the risk of someone potentially breaking this code. So there you go. Now we have a property inside of our calculator. So in this last section, we looked at properties. We looked at how we can create a property, how we can create read-only properties, and also auto properties. So in the next course, which is CSC105, we're going to stop learning new material, and we're going to focus on applying all the information that we learned in the 4 previous classes, and we're going to look at building a real-world console application. So that brings us to the end of the video for today. As always, I want to say thank you for listening, and I'll see you in CSC 105.